Hey everybody, welcome back to another quant reasoning video. This is the second part of chapter 6, unit 6b, measures of variation. And if you remember back from the 6a video, we mentioned this concept of variation. Variation is basically how widely spread out the data is compared to the center. So here, when the data is very, very close to the middle, it's all bunched up together, that's considered low variation. This is kind of moderate or average variation. This is high variation when it's spread out further. And so we're going to come up with a couple of different ways to describe the variation. The first is a very simple concept, and that's called the range. The range of a data set is the difference between the highest and lowest data values. So literally, it is the largest value in your entire data set minus the smallest value in your entire data set. And you subtract those two and you get the range, which is obviously very easy to calculate, but not very helpful, especially if you have outliers. If you have an outlier, then that's going to get your range to be a lot larger than it should be, or that variation is not necessarily representative of the overall variation for our distribution. Okay, so the range is nice, but it's easy to calculate, but it doesn't necessarily tell us a lot of information. The standard deviation, however, is the single most commonly used number. It is a number, and it's the one that's used most often to describe variation. So there's a formula there for standard deviation, but I don't want you to memorize the formula, all right? I want to show you step by step how to calculate it. I am going to ask you to calculate the standard deviation by hand. Yes, I know your calculator can probably do it. Yes, I know Excel can do it. That's not the point. The point is not, can you calculate it? The point is, do you understand what it means? And the only way to really understand what it means is to know where it comes from, okay? So another way to describe the standard deviation is it is basically the mean of the deviations from the mean. If you have a mean number for your data set, the standard deviation is kind of the average distance the points are away from the middle. That's not exactly what it is, but that's the way to kind of understand it. And there you go. So I'm going to give you a chance here. This is the 5-step process, and the handout that was included in D2L for 6B has a slide very similar to this. It's not exactly the same, but it is the same steps. And those you have to know. I will not give them to you, okay? You do have to know how to do this process by hand on the quiz coming up next week and also on the exam, okay? So understand that you need to know that. So let's walk through this process together, okay? Find the standard deviation for these 5 test scores. So all 5 of these students took this exam and they scored these different 5 values, and so we're going to find the standard deviation. Well, step 1, again, you're going to refer back to here, compute the mean. Remember, the mean is add them up, divide by the number you have. So we're going to find the mean by adding these up, 92 plus 88 plus 80 plus 68 plus 52. We're going to divide that by 5. And when we punch this into our calculator, we get 76. Okay. Now, the second step is to find the squares of all the deviations. Well, what does that mean? The deviation from the mean is how far away you are from the middle. So what I typically do is I typically make a chart. I list X, that's my data points, 92, 88, 80, 68, 52. And then the next area is X minus X bar. Sometimes the mean has a representation of X bar, and so this is the data point minus the mean. So we take 92 minus 76, and we do 88 minus 76, and 80 minus 76, 68 minus 76, 52 minus 76. So these are called the deviations. This is 16, this is 12, this is 4, this is negative 8, and this is negative 24. Okay, now, if you've done this correctly, because 76 is in the middle of all your numbers, right? If you add up the positives and the negatives, guess what you should get? you should get 0. Okay, so that's a nice way to check yourself whether or not you got it. Nothing in here says to do that. I'm just kind of giving you a little bit of a indicator of where you might be. All right, so this is the beginning of step 2, and then the fullness of step 2 is we want to take these numbers and square them. Now again, you can do that all in one step, but remember that when you square a number, you always get out a positive. If you square a real number, you get out a non-negative number. And so 16 squared is 256, 12 squared is 144, 4 squared is 16, negative 8 squared is positive 64. Remember, if you take negative 8 and square it, then you get 2 negatives. That makes it a positive, okay? And then negative 24 squared, plug that in your calculator, you get 576, okay? So step 2 is to take these deviations, find these deviations from the mean. Positive or negative, doesn't matter, but then when you square them, you get all positive numbers, okay? Step 3, add them all up. Well, that's simple enough. I'm going to add them all up. I'm going to take 256, 144, da-da-da-da-da-da. All right, so we add them all up. 256 plus 144 plus 16 plus 64 plus 576. Okay, if we type that in our calculator, we get 1,056. And then we're going to find the average, but it's called the sample standard deviation. There is a difference. There's a population and a sample standard deviation. The thing is, because we're almost always dealing with samples, we will deal with that here as well. And so the sample standard deviation comes from taking our sum here and dividing it by 1 less than the number of data points. Up here we divided by 5 because there were 5 data points we were finding the mean. For the standard deviation, we divide by 1 less than the total number. So in this case, we're going to divide by 4. Okay, so we take 1056 and divide it by 4, and that gives us 264. And then in order to kind of undo the squaring, we're going to take the square root. And you take the square root of 264, and you get approximately 16.25. All right, 16.248. Didn't say how far to round it. Okay, and so that's the standard deviation. So for these numbers, they're pretty significantly spread out. For 16 to be the standard deviation from the middle, right? They're pretty good spread out. Of course, there's only 5 of them, so there's that. Okay, so that's the process. Again, here is the 5-step process that goes into standard deviation. Okay, so here's what I want you to do. I've given you 10 test scores, and I've already calculated the mean for you. The mean is 66, n is equal to 10. And so I've asked you to find the deviation, the difference of the test score and the mean. I've written it down here. You find the deviation from the test score and the mean, then you square the difference, okay? And so what I want you to do is I want you to go through and do all of these. Hit pause, and then I want you to see if you can finish this out. Feel free to, you should have the notes printed already, but feel free to rewind the video and watch me do this again, or go back at least to this page here and get the steps down, pause the video and write these down real quick. But I want you to take a few minutes and try this on your own, just like if we were in a classroom together, okay? And then I'll come back and we'll go over the answers. Okay, so I am going to save you guys the time and go through here real quickly. Okay, so we have, these are our deviations, squaring them. We get these numbers, adding these numbers all the way up, we get 8,338. So what do we have left to do? We take 8,338, we divide it by 1 less than the number of data points, so we divide it by 9. So we take 8338, divide it by 9, and get 926.4 repeating. And then if we take the square root of that, all right, don't round off until you get to the very end, so you keep that 926 in your calculator just the way that it is. Take the square root, and you get approximately 30.4 if we round it off to the nearest tenth this time, 30.4. And that's the standard deviation. Sometimes we use the symbol sigma, little baby sigma, Greek letter, kind of looks like a 6 on its side. That's sigma, that represents standard deviation. And that's the way you go through the process. Okay? So it is a lengthy process, I know that, and that's just the way it goes, and that's fine. So there's more in section B about quartiles, but we're going to put that together in 5C, so you won't have to worry about that until next week. All right? So as always, if you have any questions, look me up and get on the My Math Lab and the worksheets and work those problems out. Practice, 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 and we'll see you later. Thanks.